We saw in the previous video from 4.2 part 1, substitution, that we can substitute if we can solve for one of the variables, either x and y, and that's easiest to do if the coefficient of y is 1, like it is here in this example. However, there is another way. So the example for substitution we're going to use is 5x plus 2y equals 9 and 3x minus y equals 1. So for elimination, what we want is we want the coefficients of either x or y to be the same. Actually, opposites. So we want those to be opposites. So it really doesn't matter. I'm going to actually choose x here and say if I want the x's to be the same, I can turn them both into the number 15. I really want one of them to be 15, so if I multiply this equation by 3, I can turn that into 15, and if I multiply this equation by -5, then I can make that -15. So my two new equations are 15x plus 6y equals 27, and minus 15x plus 5y equals -5. Now I want to add these two equations together. So we've created this nice situation where these 15x's are going to add to 0. So we'll get 11y equals 22, and we'll continue to solve for y. So we get y equals 2. Now we know that this is only one of the solutions. The other solution we have to get by plugging y into one of the original equations. Keep in mind one of the original. I'm going to choose the first one here. 5x plus 2 times 2 equals 9. So 5x plus 4 equals 9. And if we continue to solve, subtracting 4 from each side, we get x equals 1. So my solution is 1, 2. So solving by elimination, we want to create the situation like we did at the top here, where the coefficients are opposites by multiplying by a non-zero number. Then we're going to add the equations together so that one of those is eliminated, hence this term elimination. And then we will solve, and then we will substitute right here to find the second piece of the solution. So let's take a look at another. You'll notice this one has a fraction in it. We've got x minus 1/2 y equals 2 and y plus 2x equals 3. So my first thought on this one, honestly, is to take this equation and just multiply by 2. I'm not even thinking about trying to solve it at this point. I'm just trying to make my numbers look a little nicer. So that's going to give me 2x minus y equals 4, and I don't have to worry about those fractions anymore. I also am going to take this second equation here, and I'm going to write it in the same order. 2x plus y equals 3. So my x's and my y's are lined up. And you'll notice that in this particular case, I don't have to do anything with the coefficients of y's. If I add these together, these are automatically going to add to 0. So we're going to get 4x equals 7. So x equals 7/4. That's only half of our solution, so I'm going to plug 7/4 in here into one of my original. 2 times 7/4, y plus 2 times 7/4 equals 3. So this is going to give me, if I cancel, 2 goes into 4 2 times. It's going to give me y plus 7/2 equals 3. And y equals 3 minus 7/2, which is minus 1/2. So my solution here is 7/4 for x and minus 1/2 for y. So right here, if you have trouble with the fractions, you can do those on your calculator and do math frac, or you want to turn the 3 into 6 halves. So 6 halves minus 7 halves is minus 1 half. Our last example, 2x plus y equals 8 and 4x plus 2y equals 16. So again, we can choose either x's or y's. I'm going to choose to get rid of the x's. So I'm going to multiply this equation by negative 2. So that's going to give me negative 4x minus 2y equals minus 16. And then this already has a 4x, so I've got 4x plus 2y equals 16. And when we add these two equations together, you'll notice that those add to 0, but also those add to 0. So we end up with 0 equals 0. So remember, what this means is that these lines are actually the same exact line, and that there are an infinite number of solutions. And one way that we can represent our solutions is we can solve one of these equations for y. So I'm going to use this first equation here, and I'm going to subtract 2x. And we now know that y is equal to negative 2x plus 8. So the solution set is all of the ordered pairs x, y, such that y is equal to negative 2x plus 8. So this is set builder notation, which is one way to give your solution. But as soon as we see 0 equals 0, we know that we have an infinite number of solutions. That concludes this video. Have a great day.